Can you see my screen?
Yes, sir.
Okay. Okay, give me 1 minute. Okay. So we continue yesterday's lecture. This is shear stress. This is bearing stress. So it's basically it's all the same. So if you are talking about stress, so the equation is all the same. The equation is stress is equal to P or F over A. This is for normal stress. So A depends. A is the area where it is subjected to the load applied. So here this is the area. Okay, so this is a D times T. This is the area. So if shear stress, the symbol is tau, this is tau, equal to F over A, same. Except that the direction of the force is not perpendicular to the area, it is parallel. So this is shear stress. Okay, so based on the problem at the beginning, so this slide detailing the shape of the rod. This is the rod and beam. This is beam. Okay, and then it gives you the diameter, which is 20 mm, and then this size is 40 mm, and the width, the thickness of this beam is 50 mm, and the width is 30 mm. Okay, and if you look here, this is pin. This pin is 25 mm, and it has double shear here, one here and one here. This is one shear, double shear. Similarly, in here you have I think 4 shear. 1, 2, 3, 4. Okay, and this is the size 20 mm and 20 mm. What else? Other information? Other information is from here. This pin, the diameter is 25 mm, and this thickness is 20 mm. So plus with this diameter 20 mm. So this total from here to here is 40 mm. Because this one is 20, this one is 20, so 40 mm. And this pin also 25 mm. This pin. Okay. Would like to determine the stress in the members and connection of the structure shown. Okay, so this slide would like to determine the stress in the members and connection. So connection means here lah, at the pin here, this is connection, and here and in here, this is connection. Faham tak? You understand not? So the stress in the members mean what is the stress here, stress at BC, and what is the stress at AB. This is members. This is members, and here, here, and here, this is called as connection, because you are connecting a rod BC with beam AB here. This is called connection. Okay. So, but we know previously that we calculated FAB and FBC is equal to 40 and 50 kilonewton each. This has been determined in the previous slide, in the previous calculation. Okay. Okay, so the rod is in tension with axial force is 50 kilonewton. So this has been determined in the previous slide or in the previous lecture. So rod is this is point C lah, point C and point B. Okay, at the rod center, the average normal stress in the circular cross section A equal to 314 equal to 159. So how you get this 159? Okay, so this is okay. This area. This area, so the area is actually like this lah, rod. So area equal to pi r square or pi d square over 4. So if you calculate, you will get pi times r. R is equal to this one is 20. The diameter is 20. The diameter is 20. D is 20. So r equal to 10. R equal to 10 mm. So 10 m. M is milli. This one is milli. Milli is 10 to the power of minus 3. So you times 10 to the power of minus 3 because this is milli. And then you put this m. This m you put in here. So you get 10 times millimeter. And then you change this milli to 10 to the power of minus 3. And then you square root because this one has square. Okay. So you will get, if you calculate, you will get 314. Using calculator, you get 314 times 10 to the power of minus 6 m square. Or if you want me to show you how to calculate this, you can calculate pi times 10 to the times 10 to the power of minus 6, and then this one you got m times m equal to m square. So you get 314 times 10 to the power of minus 6. M square. Hmm, 100. Ini pun sama juga. So 10 to the power of, because this one you times to here, you times to here, and then you times to here. So that's why you got all this, and then finally you will get this value lah. Okay. So once you get this value, you calculate stress BC equal to F BC over A BC, and then here you get 50. This one is 50 kilonewton. 50 times 10 to the power of 10 times 10 to the power of 3 over A area is 314 times 10 to the power of minus 6. And then you will get the answer is 159 MPa. Okay. So Newton over meter square. Here this one. Newton. This one is Newton. This one is Newton. This one is m square. Newton over meter square is also can be written as nm to the power of minus 2, and this is equal to 1 PA, or 1, this one is 1 lah, 1 n over m square equal to 1 n m minus 2 equal to 1 PA. Faham tak?
Oh no.
Okay. So that means this one is actually, the value is 159 times 10 to the power of 6 times nm minus 2. So if you change this one, so this is 159 times, this one is mega, 10 to the power of 6 is mega. This one nm minus 2 is equal to 1 PA. So you change to PA. So that's why you got this unit. Faham tak?
Faham.
Faham sih.
Okay, and then so for the connection, so you need to calculate shear in here. Okay, in the flattened rod end, the smallest cross-sectional area occurs at the pin center line. So A equal to 20 times 40 minus 25. 40 minus 40, this is 40, this is 40, this 40 is belong to here, this 25 is belong to here, and this 20 belong to here. So can you imagine this 40 minus 25? So if you are imagine this connection here, so actually this is looking like this. Let me try to draw. This is 25. Okay, and then this one. So now I am drawing this area. I am drawing this area like this, and then go to here, and then go to here, and then go to here, 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 and then go to here, 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 here. Okay. So this area is actually this one plus this one. Faham tak? So this one is 40, this is 40 from here to here. So and then you minus with 25. 25 is this. Distance. So in order to get this value plus this value, you have to minus 40 minus 25. So that's why you 40 minus 25. And then this thickness is 20. From here to here, this is 20. So that's why this area you got this calculation. Okay, so this is equal to 300 times 10, because 20 times 15. Faham tak?
Faham.
Sir,
Yes.
ini untuk connection
Ya, ini untuk connection. So dekat sini. Yang kita nak kira tu, yang tadi tu dekat sini. Yang ini, yang ni.
Bukan untuk boom dengan rod, bukan?
Tak. Ni rod. Beam kat bawah. Ini BC tau. Ni C tau. B tu kat sini. A tu kat. Faham tak?
Faham.
So dekat stress dekat BC yang maksimum, stress BC dekat yang maksimum berlaku dekat sini. Happen here, occur here. The maximum stress occur at the smallest area. The maximum stress occur at the smallest area, at the smallest contact area. So the F is equal to, so stress is equal to F over A. So F is equal to 50 times 10 Newton over area. Area is 300. So you will get this value. So similarly, this one you will get 167 times 10 to the power of 6 times n over m square. Okay, and this is equal to mega, and this one n over m square is equal to 1 PA. So you just put PA here. So you will get 167 MPa. Okay. Sekejap. Okay, so and then the beam is in compression with an axial force of 4 kilonewton, 40 kilonewton, and average normal stress of 26.7. So how do you get this value? Can you try? $40. So the beam is FAB is 40 kilonewton, and the area is FAB is 40. The area is this is 30, and this is 50. So the area, this is the area. So how you get this 26.7 minus 26.7? How you get this value? How you get this value?
Tak buat lagi betul.
Guna F per A pula. Betul lah, guna F per A.
Okay, guna F per A. So ni so yang ni ialah stress AB.
So AB equal to F per A.
F
F per A.
AB per 2 AB. Berapa? F dia berapa?
26.67 MPa.
F dia berapa?
F dia 40 kilo Newton.
40 because with compression minus 40 kilonewton. Area?
Area 0.5 times 10 power of negative 3.
0 point apa?
0.5 ataupun 0.05 times 0.03.
So 0.05 times 0.03.
Yeah.
So then we will get minus 26.7 times 10 to the power of 6 times over n, this one m square, over n square. So we
Yeah.
get 6.7. So it's meter. This one is PA. So you get this value. Okay? So same.
So kenapa F negatif
Sebab the compression.
Compression.
Oh, okay. Thank you.
Sebenarnya kalau if you don't put this negative also is actually right. So let's say you put 26.7 MPa. So and then you put in bracket compression. Is also fine. It's also no problem. The negative sign is to show that this beam is being compressed. Okay, the negative sign just to show that the beam is in compression mode. Okay.
Okay, sir.
So the minimum area section at beam end are unstressed since the beam is in compression. Tahu tak maksudnya sebab macam ni, dia punya macam ni, dia punya the rod is like this and then the beam is like this. So this rod, when you put 30 kilonewton load here, so this is wall and this is wall. When you put 30 kilonewton rod here, this rod will be stretching. So this one is moving to here. So this one is actually try to stretch lah. So that's why you got stretch, you got maybe elongation, okay, because it's in tension. However, for this beam will move to here. The arrow only into one side. The arrow only into one side to go to the wall. So it is being compressed because you are pushing this beam to the wall. So that means it is unstressed. Awak tak tarik dia sebab awak tekan dia, faham tak? So that's why that's why it is like this. Okay. The pin shear stress, the cross-sectional area for pin A, B, and C. A lah. B, A at beam, B at the connection between pin and beam, and C at the rod. So the area you have to find the cross-sectional area, the area first. So area for all the pin are the same because the diameter is the same. Okay, for all pin the diameter is the same or the radius is the same, so the area will be the same. So the area is calculated using this equation and then you will get this value. Okay, the force on the pin at C is equal to the force exerted by the rod BC. Okay, force exerted by the rod BC is equal to 50 kilonewton. Faham tak? This one. So you put the value, the shear lah. Shear is equal to shear stress at point C is equal to F over A. So this is 50 over 491 times 10 to the power of minus 6. And then you will get this value. And similarly, at point A, because this is double shear, and this is 40 kilonewton, so the shear at point A is equal to F over A. Okay, this is the original equation. However, the area is 2A. So it is equal to F over 2A. Okay, so F is equal to 40 because FAB is equal to 40. So 40 kilonewton over 2 area. Area is 491. This is the area, the one that we calculate here. 491 times 10 to the power of minus 6 m square. So because this one is 2, this 2 can you can cross with this. This one become 20. This one become 20. So 20 times 10 to the power of 3. So that's why you got this one 20. Okay, because you already cancel with this 2. And then this one become 491. Faham tak ini?
Faham sebab ada single share dengan double share kan.
Betul. So dia potong dengan 2 ni. Potong dengan 2 ni sebab dia 20. So sepatutnya dia 40. 40 bahagi dengan 2.
Betul.
Okay, so you get to follow. Simple je. Mudah-mudah je. Okay. Ya. Double share. Okay. Pin shearing stress at point B. At point B. Okay, at point B. Pin B. So this pin B, so the diameter or everything is the same. So because at this connection, if you see properly, this one, it has 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then in the middle, there is one in the middle to represent the equal. So you have 1, 2, 3, 4, and then there is one in the middle. So you look at this pin has a 1, 2, 3, 4 connection, meeting point 1, 2, 3, 4. Okay, so in which that this is FAB. FAB is 40 kilonewton, and then you have FBC. FBC is 50 kilonewton. So because this is 40 kilonewton, so if you divide by 2, it will become 20 kilonewton each. Okay, at here, and it also at here. And then G and H, and then you have load 30 kilonewton. So if you divide by 2, it will become 15 and 15. So you get 15 in here and also 15 in here at point D and J. Okay, and then in the middle here, you have a connection to rod BC, which is 50 kilonewton. Okay, so the smallest force occur at pin B. The smallest force occur at pin B is equal to 15 only. This is the smallest, and the largest will be 25, because this 50 you divide by 2, 25 and 25. Because for beam or for rod, it has to what we call to junction, because the rod has to junction like this. This one, this is one, and this is another one. Sama macam ni lah. This one, ni junction 1, and then this one is junction 2. Faham? Okay. And then evaluate the corresponding average shearing stress. So shear at point B is equal to PG equal over A. The largest force is 25 and area is same, so you get 50.9. megapascal. So this is the largest, this is the maximum shear stress. Okay, because this the maximum stress occur at 25 kilonewton at one junction lah. Okay, this one and this one. So this one is 25. This one is 25, and this one also 25 at G and H. GOH lah. GOH. Okay, pin bearing stress. This one, this is pin. The diameter is 25 from here to here, and then the thickness. The thickness is, this one is 50. This one is 25. This one to here is 25. So you get here and here. You get this distance plus with this distance plus with this distance plus with this distance. So this one is distance 1 plus distance 2. So 1 plus 2 is equal to 50 minus 25. You got 25. And then 25 you times by 30. Because this is the beam. This is beam. This is not beam, This is not beam. Not beam. This one also not beam. So beam only this one. So this one is actually from here to here. So only this area is connected to the pin. So apa tak yang ni? Yang 25 ni.
Faham?
Faham Faham. So if you don't understand, then I can try to draw this, and then this, here, this, okay, and then here, and then here, and then here. Okay, so this is the area of the beam. This is for pin, which is from here to here. This is 25, and then this thickness from here to here, how do you say it? From here to here, this one is 50. This one is 25. So you get this, this is 1, this is 2. So 1 plus 2 is equal to 50 minus 25. You got 25. And then this, from here to here, the value is equal to 30. So the area is equal to this one lah. T times D equal to 30 times 25. Faham tak?
Okay.
So the stress is equal to F over A, in which that F is equal to 40 over area, 30 times 25. So you get this value lah. Determine the bearing stress at A in the bracket. We have T equal to 225, equal to 50, and D 25. Okay, this bracket, in the bracket, This is called bracket. This is bracket 1. This is bracket 2. So similarly, because because it has 2, so 2 times 25. This one. This one also same. This area. So this is one bracket. This is bracket 1. Bracket 1. So you also get 25, which is 50 minus 25. You got 25, and then for bracket 2, in this is bracket 1 here. This is bracket 2. So same. So that's why you got 25 times 2, or 25 plus 25. So that's why you got 50. Okay, and then the D is 25, which is this one. So the area is 50 times 25. So bearing stress equal to 40 over 50 times 25, equal to 32. Faham tak?
Okay, saya nak tanya, sir.
Mhm.
Untuk beam ni, di sini akan bagi bracket kan. So bracket tu kita kena apa tu? Sekalikan campur kan. Kena cakap betul.
Sebab ada dua. Sebab ada dua cabang.
Dua cabang. Untuk yang atas ni dia biasa je.
Yang
Satu
atas,
je. Yang bawah ni satu, yang atas tu.
atas tu maksudnya apa?
Tak,
Rod ke?
maksudnya dia, atas tu beam kan?
Atas ni pandangan atas dia.
Oh, pandangan atas je.
Ni pandangan atas dia saya rasa ni. Ni pandangan bawah dia. Ini pandangan sisi. Ini
Pandangan sisi, ni pandangan atas kan?
view.
Top view and right view kan?
This is top view.
Oh.
Dia tunjuk benda yang sama sebab awak tengok ni A, ni point A juga. So actually
Sebab dia kata yang terus tu je.
okay, this is side view, this is top view. So it is the same thing. Okay, ada question no? Okay, good. Stress into force member. Tak lah. Stress on an oblique plane. Lah, I think maybe until next week lah. Good. But already at 9:50. We continue the lecture next week. I will try to figure out how you can view the recorded lecture, and then I will tell you how you can see, because now you cannot access the video yet. I will look at it. Okay. Okay. Have a good day. Okay, and bye.
Thank you, Doctor.
Okay, sir.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir.